Have you ever really stopped to think about the magic that's happening inside the most ordinary objects you use every single day? Well, in this explainer, we're going to do just that. We are pulling back the curtain on the incredible science that's hidden in plain sight. Just think about your morning. You wake up, you tap your phone, you pop something in the microwave, you grab your keys. It all just works, right? It feels so straightforward, almost second nature.
But is it, really? Because behind every single one of those simple little actions, there's a world of absolutely mind-blowing science at work. And what's so wild is that it turns out the things we know best, the stuff that's all around us, are often the most scientifically brilliant. So yeah, let's look a little closer. Okay, so our first stop is wrapping our heads around this key idea, what I like to call the illusion of simplicity. Think about it. The better a piece of tech works, the more all of its insane complexity just vanishes.
What seems totally intuitive on the surface, well, it often involves deep layers of physics, material science, even quantum mechanics buzzing away behind the scenes. See, seamless design isn't about getting rid of complexity. No way. It's about mastering it so completely that we, the users, never even have to see it. It's the kind of engineering that really does feel like magic.
All right, let's start with something I bet you've already touched today, your smartphone screen, right? It feels so direct, like you're literally pushing that icon around with your finger. But what's really going on under the glass?
Well, the whole secret comes down to a property called capacitance. See, the screen holds this perfectly stable, completely invisible electric field, and you, your finger, are a natural conductor. So the moment you get close, you actually disrupt that field.
So how does that little disruption turn into a command? Well, there's this invisible grid of conductors on the screen, creating that electric field we just talked about. Your finger comes along and messes with the field at one very specific point. Instantly, super-sensitive sensors detect that tiny change, and powerful algorithms translate it into the exact swipe or tap you want it to make. It's like this lightning-fast conversation happening between your body and the phone's physics.
And when I say sensitive, I mean sensitive. These sensors can detect changes measured in, get this, femtofarads. What's a femtofarad? It's a quadrillionth of a farad. That's a 1 followed by 15 zeros. It's an almost unbelievably small unit of measurement, and yet your screen detects it effortlessly, every single time.
Okay, let's move from our pocket to the kitchen. Let's talk about the humble microwave oven. Its job seems dead simple, right? Heat food, fast. But the way it does it, that is pure, unadulterated physics.
You see, a conventional oven is all about heating the air around your food, so it cooks from the outside in. A microwave, though, is way more clever. It shoots these invisible waves directly into the food, and they're perfectly tuned to make the water molecules inside go absolutely nuts. They start vibrating like crazy, creating all this friction, and that's what generates the heat, basically from the inside out.
Which, of course, leads to that classic question we've all wondered about at some point. Why does the food have to spin around on that little turntable? Is it just for looks?
Oh, not at all. It's actually a really brilliant, pretty low-tech solution to a very high-tech problem. See, the microwave energy inside that box isn't spread out evenly. It creates a pattern of what are called standing waves, which basically means you have invisible hot spots and cold spots. If you didn't have that turntable, one part of your food would be blazing hot and another part would still be frozen solid. By spinning the food, you make sure every single bit of it passes through those hot spots. That's how you get a nice, evenly heated meal.
So the smartphone and the microwave, those are just two examples. But here's the cool part. Once you start looking for it, you start to see that this invisible world of science is, well, it's everywhere.
It's truly all around us. That car key in your pocket, it's using rolling code cryptography, changing its password every single time to stop thieves. Your refrigerator? That's a heat pump, using thermodynamics to literally pull the heat out from the inside and dump it outside. Your Wi-Fi? That's a masterclass in wave physics, encoding all your data onto radio waves. And the humble LED bulb? You guessed it, it's using quantum mechanics to make light super efficiently. It's just everywhere.
So I know all this complexity can sound a little overwhelming, but it all points to this one really surprising conclusion about the technology we use. All that complexity, it's not a bug. No, it's the ultimate feature. The whole point of all this deep, complicated, layered science is to create an experience for you and me that feels simple, that feels intuitive, that's basically invisible. The real genius is in hiding all the hard work. So the next time you pick up some simple little device, just pause for a second.
Look a little closer and ask yourself, what other invisible science is hiding in plain sight, powering my life right now?